going to look now at another equation that we can use when calculating the speed of waves. So the one we have just looked at is speed equals distance over time, which is written in our equation sheet as d equals vt. The second relationship that we can use for waves is speed equals frequency multiplied by wavelength. So wavelength and frequency are a couple of properties of waves that we already know a little about. If we multiply frequency by wavelength, then we can get speed. So just like we use some lettering for our equation here, predictably we use F for frequency, but a little confusingly we use a Greek letter for wavelength, simply because the English alphabet letters were already taken by that point. So we use a Greek letter lambda, which looks a wee bit like an upside down Y. We have been introduced to lambda previously, it's just this is the first time we've seen it in an equation. So our units for the first relationship were time is in seconds, speed is in meters per second, distance is in meters. Our units here, we still have speed as meters per second. Our frequency we measure in hertz, uppercase H, lowercase z, and our wavelength we measure in meters. So the only real new unit here is this value of hertz for frequency. If we were to write those relationships as equation triangles, then we would have d, v, and t, and we'd have v, f, and lambda. So if that makes it a little easier for you to rearrange the equations, then completely feel free to do so. Basically, if you cover up something, then it tells you what equation you've got left there. So if you cover up v, you get d divided by t. If you cover up t, you get d divided by v. If you cover up d, you get v times t. Same over here, cover up v, f times lambda, cover up f, v divided by lambda, cover up lambda, v divided by f. So it gives you your three versions of the equations. And really what you've got to do is choose which of these two equations to use depending on the information that the question has given you. So there will be some situations where you need to use speed, distance, time. There'll be some situations where you need to use speed, frequency, and wavelength. So I'll run you through some examples using v, f, and lambda. So our first example, got a sound wave with a frequency of 33 Hertz. It has a wavelength of 10 meters. Calculate the speed of the sound wave. So we know it's v that we're trying to find out. We've got f, it's 33 Hertz. Lambda for wavelength is 10 meters. V equals f lambda is the equation you'll get in your National 5 physics equation sheet. 33 multiplied by 10, nice and easy. There's that 330 meters per second again that we've seen in previous examples. That's around about our value of 340 for the speed of sound. This is a standard 3 marker again. So notice what I'm saying about different equation, same technique. One for the equation, one for the substitution, one for the final answer, which must be the number plus the units. Example 2. Find the frequency of a wave which moves at 1500 meters per second and has a wavelength of 3 meters. So we know that v is 1500 meters per second. Lambda for wavelength is 3 meters. F is our unknown this time. Now what I'm going to get you to do here is just write out the equation as it would be from the equation sheet. So we'll just write v equals f lambda before we do any rearranging. It just helps you to bag more marks because you're guaranteed that first mark there. If you rearrange incorrectly on the next line, then you're still always going to get 1 out of 3. If you look back at the equation triangles that I showed you, you'll see that we're trying to deal with f. So if you cover up that f, you get v divided by lambda. So v divided by lambda, 1500 divided by 3, 500, and our units, remember, are Hz for Hertz, 500 Hertz. Example 3, we've got a generator in a pool creating waves with a wavelength of 0.2 meters. The speed of the waves is 1.5 meters per second, and again we're looking for the frequency. So lambda for wavelength, 0.2 meters. Speed of the waves, 1.5 meters per second. Frequency, don't know. Grab the equation straight from the equation sheet, v equals f lambda. F, v divided by lambda, 1.5 divided by 0.2, 7.5 hertz. Easy. Last example, looking for wavelength this time. What's the wavelength of the waves if they've got a frequency of, that's 4 million hertz, and a speed of 20,000. Frequency, 6 zeros there. Easy to write too many or too little. Speed, 20,000 meters per second. Lambda is the unknown. Pop that equation in. Just good practice to do that. V divided by F if you use your equation triangle, or you might be able to figure that out for yourself anyway. 20,000 divided by 4 million gives us 0.005 meters. Okay, off you go and try the quiz on speed, frequency and wavelength.